So 3.7 gets into the first of the four market structures that we're going to look at. And so up to this point, we've kind of looked at production, what it takes to produce a product, and most importantly, that marginal revenue equaling marginal cost concept, that a firm will continue to produce as long as the marginal revenue, the money they're bringing in for the next unit, is greater than the marginal cost, what it costs to produce the next unit, meaning they're still earning some kind of profit. When they hit that point, the marginal cost becomes greater than marginal revenue, they'll no longer do it. When we bring in perfect competition, now we add in, we talked a little bit about marginal revenue. For right now, it's the same thing as the price. So now we're going to compare, what is the price, the marginal revenue, and then we're going to have those cost curves, and we finally put everything together from the past 3 units today into one big happy graph. So, characteristics of perfect competition. There are hundreds, if not thousands, of sellers in this market. They're all small firms selling what we call identical products, meaning if you were to look at it, you cannot tell the difference in the product without some kind of outside information. A lot of times we use agricultural products for this. If you had 2 apples, if you didn't have any outside information, you can't tell where those apples came from. Those are identical products. So that's all we're referring to. Low barriers to entry and exit means firm can enter and exit into the market very easily. If you want to sell tomatoes in the tomato market, we'll grow some tomatoes, show up at the farmer's market, sell your tomatoes, there you go, you're good to go. There may be a form or something you fill out. If you want to sell corn, we'll quit growing tomatoes, start selling corn, and there you go. You left one market, you entered another market. It's real simple. Firms are going to enter and exit into these markets constantly based on whether current firms are earning a profit. If the current firm is earning a profit, new firms are going to enter into the market to try to steal some of that profit away. If current firms are taking a loss, then firms are going to leave that market and try to go do something else where they can earn a profit. They're going to go chase it somewhere else. We talk about seller has no need to advertise, and firms are price-taking firms. So ultimately, there's going to be one market price that all of these thousands of firms are going to have to accept. Because if they try to charge higher than the market price, well, there's thousands of competitors selling it cheaper than them. So no one's going to pay the higher price. At the lower price, they say, well, I'm going to drop the price and try to, steal customers away. Well, customers are still going to buy the same amount at that original price. And so all it's going to do is cut into their profit margins if they try to lower the price. Because if you go to the store and you're going to buy 3 tomatoes, well, you're going to buy it at the market price just as easily as you're going to buy it at the lower price. You're probably not going to buy a bunch of extra just because the price is a little bit cheaper. You're going to buy that set amount. And so because of that, there's no incentive for firms to raise or lower the price. And so that's what we refer to as price-taking firms, that they're going to accept that market price. Otherwise, their profits are going to fall to zero if they don't accept the market price. And then we refer to it as they have no control over price. So that's explaining the same thing, is that firms are just going to accept that market price, whatever it is. And so what we're about to see is you're going to have 2 graphs that we refer to as side-by-side graphs. You're going to have the market, which is supply and demand curves. That's every producer, every consumer in the market. And then you're going to have the firm on the right side, which is your cost curves. And we're going to compare the 2 graphs. So on the left, you have the industry or the market. You have supply in red, you have demand in blue, equilibrium price of $10, equilibrium quantity of 5,000. That should all be very familiar at this point. So $10 is your market price. Well, if we go straight over, that price, which we've already referred to as the same thing as marginal revenue for the firm, just goes straight across the entire graph. And so whatever this market price is over here on the left becomes a perfectly elastic demand curve for the firm. We're going to talk, it actually serves 4 different purposes. We're going to get to that. But the big thing is that price is going to come all the way across. When we refer to it as a price-taking firm, that's the price they're going to take. And so this is your marginal revenue, this is your price for the firm, and then we'll get into why it's a perfectly elastic demand curve. If you remember back, we saw like one slide that had the 5 different slopes of the demand curve, and I said, hey, this perfectly elastic one we'll come to in Unit 3. Well, this is where we come to it. So, perfectly elastic demand curve. But the big thing is, this is marginal revenue and price. Reason that we refer to that price as marginal revenue is, remember, it's the additional revenue for each new unit sold. Well, if the price is $10, you're going to get $10 for the first one, $10 for the second one, $10 for the third one, Marginal, add 1, look for the change. So that's the additional revenue you're going to get from selling each one. If we produce pizzas and we sell them for $10, you're going to get $10 for every single one. That's your marginal revenue equal to the price. So, this right here, in the world of economics, is referred to as Mr. DARP. And what that refers to is that this one curve represents marginal revenue, it represents demand, it represents average revenue, and it represents the price. This is accepted on the AP test. And so if you're working with perfect competition, you can write, it's better to put the little equal signs in there, but if you were to just write Mr. DARP on the test, your readers are going to know what that means. It's pretty universally accepted throughout AP Micro that this one curve represents those 4 different aspects. Reason being, it's the marginal revenue curve, because we know $10 is the additional revenue we're going to receive for each new unit. It is the demand curve. And so consumers are it's not going to change. And so ultimately this represents all the consumers for this firm in the market. And so it's perfectly elastic. Bless you.
Thank you.
Average revenue, well, if everything costs $10, well, it's going to be the average no matter how many units you sell. And then the price, which the big one right now is price and marginal revenue. So, make a note of that, Mr. DARP, because that's kind of the safe way to answer it too. That if it wants, if it says draw a perfectly elastic demand curve for the firm, or draw the average revenue curve for the firm. Well, if you just label it Mr. DARP, you're going to get it. At some point, you're going to get it right because you've listed all 4. So it's the safer way to label things. All right. We've seen this before, but to review, so this is comparing marginal revenue to marginal cost. The price, which is the marginal revenue, is $10. The marginal cost of producing this unit is $5. So it costs you $5 to make it. You can sell it for $10. Are you going to produce it? Yeah, you're going to earn a profit. If a business can earn a profit, they're going to produce it. All right, what if it costs you $9 to make it? You can sell it for $10. Are you going to produce it?
Yeah.
Yes, you're still going to produce. Some people like to argue that and be like, well, I wouldn't sell it because I don't make as much money. No. If you run a business, you're never going to turn down profit. Profit is profit. And so you're always going to produce the next unit if you can earn that profit. Behind this box, you can't really see it, but it says $11. So if it costs $11 to make it, but you can only sell it for $10, are you going to produce it? No. At that point, your marginal cost of production has exceeded your marginal revenue that you can get for the product. You would not produce that unit. So that's why marginal revenue equal to marginal cost is your profit maximizing rule. Or really, we talked a little bit about the better way to phrase it is that as long as marginal revenue is greater than or equal to marginal cost, you're going to continue to produce. Because remember, it's not always going to be perfectly equal on the test. There may be a point in between, and so you're looking for as long as marginal revenue is greater than or equal to marginal cost, you'll continue to produce. So, we got the market or the industry on the left. We can see an equilibrium price of $7, equilibrium quantity of 10,000. These are price-taking firms for perfect competition. So the firm is going to accept that as their price. Now we throw in our cost curves. So now we have marginal revenue. Remember, this Mr. DARP, marginal revenue, and marginal cost. We know whatever that quantity is right there, which it doesn't draw a line. But if you were to go straight down, we know that is our profit maximizing output. What we're about to look at is, given this graph, you should be able, not yet, but in a minute, be able to make a determination of whether this firm should continue to produce, and specifically how many units they should produce to maximize profit, where they're going to make the most money. So, if you were to be given this graph, we can see marginal revenue is at $7. We have M equals MC here, which is the most important point. Whenever you are dealing with a market structure, this goes for perfect competition, and then the other 3 we're going to get to in Unit 4. You always find this point first. No matter what, you have to recognize this point on the graph, and then you draw that line straight through, like we did when we were calculating the different boxes for the different costs. You do the exact same thing here. You find M equals MC, you draw a line straight through your graph. So there. Now, you're looking for those intersections of where it hits these other curves. And so then you can form the boxes just like we did with the cost curves. So total revenue. Revenue is the amount of money a business brings in before they have to subtract their cost. So We know 9 units is going to be the profit maximizing output. If they produce and sell 9 of whatever it is, 9 pizzas, 9 cars, whatever, that's where they're going to maximize profit.
How do you know that? Is that just because the box there?
For right now, just because that's where this point right here is. We're going to go through the math in a minute, and I'll show you a good example of how they maximize profit at this point. But for right now, just know it's
So
because...
it's just where it crosses the Mr. Dark?
Yep. So where the black line crosses the red line,
Okay.
that's your profit maximizing output. Wherever that comes straight down, whatever that quantity is. But if we take 9 units times $7, our total revenue is $63 that this firm brings in. Then we can find that intersection where you drew this vertical line and determine our total cost of $45 to produce those 9 units. All right. Gracie,
Wait,
you're confused.
Why is it?
How did you?
Why did you stop at 5?
Yeah, that's what I'm wondering.
All right. So
How do you know to find that?
So you find this point, you go straight down, you determine 9 units. So you're going to draw this dotted line.
Oh, it's where the blue crosses it. Look.
Yeah, so you're going to draw this vertical line through your graph. And then where it intersects right there, you're going to go straight to the left like you did when we first looked at cost curves, where you're forming those boxes.
So where the blue line crosses the dotted line?
Yes.
Yeah.
So where the blue line crosses the dotted line, you go straight to the left. And that determines, because remember, average, these are per unit cost. We're talking about the averages. So 9 times 5 gives you a total cost of $45. Gives you an average of $5 a piece. Because if you take 9 units and a total of 45, well, the average for each one of those 9 units is $5. That's what you're actually graphing here. And so that's why it's 5 here, because that's the average for each of these 9 units. You multiply it out, that's how you get a total of 45. Questions?
Will those abbreviations be labeled already on the exam, or do we put it there?
No, you should be able to draw this graph by the time we're done. Actually, to complete the worksheets, you're going to have to be able to draw these graphs. I'm going to show you some shortcuts that'll make it much easier. But that's where you need to be familiar, because these abbreviations are universally accepted. You can use those on the test. So instead of having to write out marginal cost, average total cost, marginal revenue, demand, average revenue price, just use the abbreviations. It saves you and your reader tons of time. But anyways, total revenue is 63, total cost of 45, gives you a profit of $18 because you have a revenue greater than your cost. Total revenue, the amount of money comes in, total cost, the amount of money goes out. The difference is $18, the amount of money that this firm gets to keep at the end. If this point right here, MR equals MC, that's all important point that you have to be able to find if you have any hope of passing the AP test. If it is above the ATC, the firm's earning a profit. And so we're going to look at so we've seen shutdown point, which is going to be down here. We don't have an average variable cost, so we can't determine shutdown using this graph. But we've seen shutdown, where MR equals MC is below the ABC. And so now we're finally looking at MR equals MC above the ATC, which is a profit.
So the entire rectangle except for total revenue, but those two smaller rectangles or boxes, total cost is what you put back into the business, right?
Well, total cost is what you have to pay. So this is paying your employees. This is,
It goes into the business.
well, revenue comes in. So when you sell, if this is pizzas, if we sell 9 pizzas, we're going to collect $63 from the customers. When we pay our employees and we buy our resources, we have to pay out $45.
And then the rest is what you don't have to put back.
Well, this is what goes in the bank. Profit's what you get to keep after you subtract your costs.
So not just take 63 and subtract 45?
Yeah. I mean, you can do it with the box. I mean, you can say 2 units times $9 is going to give you 18. So really, are you more visual minded or are you more mathematics minded? It doesn't matter. It works both ways. You can come to the correct answer. It's just really how your brain works. Either, I mean, you need to be able to do any and all of the above because you don't know how they're going to present it on the test. But you can do it from a math standpoint or you can do it from a graphing standpoint.
So
Can total cost be seen as what has to go back into making whatever product you're selling?
Yeah, I mean, cost is just what you have to pay.
And then profit is what you keep for yourself?
Yeah, profit's what you get to keep after you subtract your cost. So now, suppose the market demand falls. For whatever reason, demand is going to decrease for this product. If people don't want pizza, whatever, they think it's unhealthy, demand's going to drop in the market. So what's going to happen? Price is going to drop from $7 to $5. So, what has changed? Marginal revenue was here. Now it's down here. Because remember, over here somewhere, you have that supply and demand curve. And so that demand curve, and we're going to look at curve shifts later on where you can actually see it, but you've got supply and demand. That downward sloping demand curve has shifted to the left. And so the market price has decreased over here. These are price-taking firms, and so they have to accept that new lower price in the market whether they like it or not. They have to accept the new price. So marginal revenue, or Mr. Dart for the firm, has decreased from $7 to $5. The cost curve for the firm has not changed. Their cost of production is still the same. It's just the market price they can charge has decreased. So now, you find MR equals MC. That's always the first thing you do, and draw that vertical line all the way through your graph. Don't just stop here, go all the way through. It's not going to penalize you. Then, you got to calculate your revenues and your costs. So, 7 times 5, we get a total revenue of $35 because they're going to sell 7 pizzas. They're going to charge $5 a piece. They're going to bring in $35 of revenue. So the price went from $7 to $5. So the only thing that's changed is this Mr. Dart curve has dropped down $2.
But it told you that, right?
Yes.
Okay.
So we just saw total revenue of 35, and then at that point, now our cost is up here. So we have a total cost of $42. So now our total cost is greater than our total revenue. So the firm is actually losing $7. Now, when we talked a little bit about shutdown rule, we don't know enough information yet, but eventually you would have to make the determination. Should the firm continue to produce at a loss, or should they shut down production altogether? Remember, it's based on the fixed cost, whether it's cheaper to keep producing. But anyways, right now, all we know is that here is our profit maximizing output. So, at that point, is the point of least loss is another way to look at it, and this may make more sense to some of y'all. So at any other point, any other quantity, you're going to lose more than $7. And so for this firm, even though they're not maximizing profit, they're minimizing their loss at this point, because any other point they're going to lose more than $7. And so it's still the profit maximizing output, even though they're not earning a profit. Does that make sense? Okay. Think so. If not, just go with me on it. So now let's assume that market demand falls even more. So we started at $7 equilibrium price in the market. We just dropped to $5. Now we're going to drop to $4 for the equilibrium price in the market. These are price-taking firms, and so they're going to have to accept that new price of $4. So now we throw in an average variable cost curve so that we can make the determination of shutdown rule. And remember, the gap between these two is our fixed costs. Is how we determine that. So we don't have an average fixed cost curve, but the distance between a TC and a VC is your fixed cost. So there's Mr. Dart. What?
Is it the fixed cost or the average fixed cost? Because it looks like it changes.
Well, I mean, from there to there, this space in between, that's your average fixed cost. So whatever the difference is between those two represents the average fixed cost.
So it's like the average fixed cost change the quantity? Because like it gets smaller?
Well, let's say average fixed cost is $10. I don't know what it actually is up here, but 10 divided by 1 is 10, divided by 2 is 5, 3, 3, 3. So that's why this gets closer and closer together, because that average fixed cost is just going to get smaller and smaller. So that's one we refer to that if you've worked with asymptotes, it's kind of the same concept. You're going to get asymptotes. I don't know if I said that right. Asymptotes, whatever. You know what I mean. I don't teach that class. But it's going to get closer and closer, but it's never actually going to touch. That's the whole deal there. But anyways, back to econ. So, MR equals MC at that point right there. If it ever crosses twice, you're going to go with the greater quantity. You're going to go with the intersection on the right. if it ever crosses twice. So we can see there is our total cost, $35. And so 7 units, our profit maximizing output is 5, so they're going to $35 a cost. Total revenues of $20.
Sorry.
So how much is their loss?
$15.
$15. So the firm is losing $15. Our fixed cost, hey, I was right, fixed cost is $10. Ooh. So if the firm continues to produce, they are going to lose $15. If they shut down altogether and produce nothing and only pay their fixed costs, they're only going to lose $10. Which is smarter?
Shut down.
Yeah. They're going to shut down production and produce nothing and just pay their fixed costs. Remember, things such as rent represent fixed costs. So if you produce nothing, you still got to pay that rent, but it's going to be cheaper than continuing to produce and have to pay the $15. From a graphing standpoint, if MR equals MC is below AVC, the firm's in shutdown. That's the way to recognize it on the graph. If it gives you the numbers, you can always check yourself, but that's the easiest way, that if this point is below average variable cost, the firm's going to shut down. If it's in between, they're going to continue to produce at a loss. If it's above ATC, they're going to earn a profit. Obviously, they're going to continue to produce. So just different things about M equals MC. It applies to all markets, and so that's why I say it's always the first thing you're going to do. No matter which of the 4 market structures you're working with, you have to find M equals MC first. Draw that line straight through your graph. Rule applies only if the price is above the average variable cost, because if not, then the firm's going to be in shutdown. And then just for perfect competition, you can reinstate the rule that price is equal to marginal cost because of that Mr. Dark curve. That price and marginal revenue are the same. Now when we get to the other market structures, price and marginal revenue will no longer be the same.
How do you
But-
know which market structure it is?
You'll be able to recognize them because they're going to look different, the graphs.
Okay, so will they always give you Mr. Dark?
For perfect competition, yes.
Okay.
But for the other market structures, no. Well, Mr. DARP is only for perfect competition.
Okay.
Later on, we're going to split demand and marginal revenue, but they're both going to be downward sloping. And so
Right.
that's the next progression of the graph. So contain your excitement. All right, so we're going to run through a little bit of practice, and then I'll probably give you a break because I feel like this is a lot for y'all to take in on a Monday morning. So, but
Are we gonna have a work day tomorrow?
yeah.
Good.
So,
I need about 4 more too.
looking at this graph, should the firm produce? You've got to be able to recognize the points.
Yes.
Yes. Why?
Because it's above
ATC.
It's above.
Very good. M equals MC is above the ATC. So that automatically tells us, yes, the firm's earning a profit. They should produce. So then we go in. All right, what output should they produce? 10 units. So you find M equals MC. You're going to draw that line straight through your graph. Tells us 10 units is the profit maximizing output, where they're going to maximize profit. Go through, calculate your boxes. Does it not tell us? Oh, there it goes. All right, so total revenue, $140. Gets- What?
Nothing.
You see it now?
Yep.
Got it? All right.
So like at 12 units though,
Which will be
and $14, wouldn't they make more money?
No, because their cost is going to increase, and so they're not going to earn as much profit. So they're going to have greater revenues at 12 units, but not greater profit. And so that's when we talked a little bit, or I kept referring to, we're not going to maximize revenue and we're not going to minimize cost, because here would maximize revenue. There would minimize cost. Neither one of those points, 7 or 12, is going to maximize profit.
So you want kind of in the middle?
Well, it's just always M equals MC. That's always going to maximize profit. Because that's the last point we know of to where if we were to produce one more unit, we cross that threshold of cost being greater than revenue. And so up until that point, we're still having revenues greater than cost. And so we're squeezing out every little bit of profit, and then we cross that threshold.
We cannot use a calculator on the test?
What?
We cannot use a calculator on the exam?
No.
the MR, the Mr. Dark one.
But you can multiply 10 times 14.
Yeah, I can do that. I guess it's more complicated than that now.
It should be. Remember, it's not a math test. They don't care about your math skills. They care about your economic understanding. But anyways, let's get through some of this. So Total revenue of 140, total cost is there, $100, 10 times 10. So, if they have revenues of 140, cost of 100, what's their profit? $40. So, great for them, firm made $40. Going back, you can see it on the graph. Or you can find the difference there, 10 and 14 times 10 gives you 4 times 10, 40. That's another way to find it if you're more of a visual person than a math person.
We're not ever gonna have to draw the lines, right? Like
Yes, you are.
Okay.
But I'm going to show you some super simplified ways that you can draw this graph in about 3 seconds. Because it's not really, they're never going to really give you all the little points that you have to draw, but you're going to have to draw a generalized marginal cost and ATC with a Mr. Darp in there.
We're gonna have to draw that based off a table.
Probably not. They're not going to give you all the little points to graph, but you may have to draw a cost curve graph. And so I'll show you an example in a minute. It'll make more sense. But anyways, let's run through one more of these. So based on this, should the firm produce?
No. Well, ATC is above MC.
So is the firm going to produce? You sure?
No.
Well, I was sure.
They're gonna produce at $6 or 6 quantity.
Yes. So 6 units is going to maximize profit.
Yeah.
So remember, if MR equals MC is below ABC, the firm's going to shut down.
Yeah.
If it's in between, they're going to continue to produce at a loss.
And that's okay.
Yes, because if this firm is losing money, other firms are going to leave the market to go do something where they can earn a profit. Well, the customers they leave behind, the firms that stick it out, are going to absorb. And so we'll look at how that changes things for the firm that sticks it out, but eventually they're going to break even. Because the last thing we do, or really, well, yeah, is we're going to look at short run to long run, and then we actually go long run to short run to long run production for these firms. We'll get to all that fun stuff. But anyways, just being able to calculate it right now is a big part of this. So total revenue is at 90, total cost is 120, so that's a $30 loss, but they're still going to continue to produce at a loss.
Here they're gonna shut down though, right?
What?
They're gonna shut down right here though. Because MC is lower than 82.
No. Because there's M equals MC. If it was
Oh, you're
yeah.
right. Yes. Okay.
So, because if we were to
I was
calculate, I don't know, what is,
$12.
I was looking
well,
at
it's not
three.
quite 12. We'll call it $13. So 7 times 6, so 42. So if they were to shut down, they're going to have to pay that fixed cost of $42. If we assume
Right.
that would be 13. If they continue to produce, they're only losing 30.
I was
so
looking
it's-
at the 3, not the 6.
Gotcha. Yeah, don't do that.
But now this is where they're gonna shut down.
Yeah. So this is an example of shutdown. M equals MC is below the average variable cost. So if we go through everything, where to go, we can see that it's cheaper to pay the fixed cost of $5, 1 unit times 5, than it is to pay the $10 of actual loss. It's cheaper just to shut down and produce nothing.
Thanks.
We feeling better about that point?
Yes.
Okay. Then we'll move through because there's a bunch of practice on this. So this is what I was talking about. I'd show you where they're going to maximize profit. So marginal revenue is at 30, marginal cost 20. So yes, they're going to produce it. At this point, marginal cost becomes greater than marginal revenue, and so they would not produce that unit. So at 5 units is where they're going to maximize profit. So they're still going to earn a profit at 6 units. If they were to produce that 6 unit, they still earn $60 profit, but they're starting to lose money for each additional unit they produce. And so that's why they're going to stop at the 5th unit, because that's when that whole term, when we say maximize profit, that's what we're referring to. Is that at that point, that's where the profits are going to be greatest. Anything past that, they start to lose money, which defeats the purpose of running a business, is losing money. So this just shows you that, yes, they're still going to earn a profit at those other points. They're just not going to maximize profit. So and once again, they're not going to maximize revenue because they could still earn higher revenue, but they're going to lose money doing it. Or to minimize costs, which we can't, well, can we? No, it doesn't give us average total here. So anyways, does that make more sense from a table standpoint of why that M R equals MC is going to maximize profit. All right, we'll do this and then we'll stop. So I'm going to show you 4 graphs. You're going to tell me which of them is labeled correctly for a perfectly competitive firm earning a profit. So take a minute, look at these, tell me which one of those 4 is correctly labeled for a perfectly competitive firm earning a profit.
I think MC is supposed
No.
Yes, it
Yes, yes.
So it's not.
I'm gonna.
is. It's not one.
It's
or
3.
4.
It's 3.
You think 3?
Mm-hmm.
Yeah, it's 3.
It's 3.
be.
It's 3.
It's Here's the thing.
Anybody agree or disagree?
I think
I think it's
I heard it 4.
It's
No.
It's not 4 because MC is labeled right.
Yeah, the MC is the red line.
Oh, right. But three's off though. The green box.
But that's the profit.
It's 3.
Which one is it?
The real funny one is 3.
I'm telling you one.
Yeah, I was like, wait, the green box is.
Sorry, that's correct. My entertainment. So they're all wrong. Let's talk about why they're wrong though. Because here's the teaching point of this. Here's why this is actually important. Because these little differences, you'll lose the point on the test. That if you are not very specific in your graphing, you won't get the point. And that's why you also need to get in the habit of when you draw graphs, and you're probably going to have to draw graphs to answer the worksheets. The rule is typically about the size of your fist is what they like to see. Don't draw this little bitty graph thinking you're going to because if they can't read it, they're not going to give you the point anyways. And so if you're going to be wrong, be gloriously wrong in your answer. Don't try to cheat them because they're grading, thousands and thousands of tests.
By hand?
Yeah.
Whoa.
So your average reader at the reading is what they call it. Sounds super serious, but they typically grade, I think, 400 to 500 exams a day over a period of 10 days, and there's a whole room of them. So they're not going to take the time of, well, did they do it? Did they not do it? So you've got to be able to clearly show. But anyways, the reasons these are wrong. So M R equals MC is below the ATC. So the firm is taking a loss because their cost is greater than their revenue. Number 2 is wrong because they didn't extend this far enough. And so there's M R equals MC. They're showing their point back here, which this is an actual point. We'll talk about what it is later on. But it should have been here instead of here. So it's too far to the left. This is wrong because they came too far below the average total cost curve. So this would have been right if they were just stopped at the blue line, came across. So you got a little bit too much green box at the bottom down there. And then as someone said, these are labeled incorrectly. So this is drawn correctly, but their labeling is wrong. And so you would lose the point for all 4 of these, unfortunately. And let's stop there for today.